Morning, y'all. My throat's a little chopped up. I'll be all right though. Just my voice might sound weird, and yeah, sorry about that. Yeah, if you go ahead and start on the warm up, we'll start on start going over some stuff. Probably around 9:06. Feel free to throw something in the chat so I know you're here, or say hello, or to complain about your weekend, to brag about your weekend. Hi, tired. I'm Mr. Pet Mickey. But yeah, I get that. It's really easy to fall into the trap of not going to bed early. I know, Claudia, I'm sorry. But this way, you can get all your math done, and then you can do the worksheet afterwards real quick. It's like 12 problems, so hopefully be okay pretty quick. And then you can just relax the rest of the day and be happy. No, don't go to sleep. We have to do a lesson. Hopefully we're in and out 20 minutes the most. Let's say 30 actually. Absolutely, Jolie, 100%. All right, my ideal timetable, okay, Jolie, is 9:06. Start going over the warm up. Be done with the warm up by 9:10. It's 9:06 now. Then from 9:10 to 9:20, talk about the Pythagorean theorem. From 9:20 to 9:30, talk about distance formula, and then be done. So hopefully we're done by 9:30. All right. So we got these two formulas, okay? So we're trying to find the lines perpendicular to y equals negative 2x plus 3 through 4/3, right? So if the slope right now is negative 2, right? But we got to flop that, right? So it then becomes negative 1/2. And then change the negatives, it becomes 1/2. So the slope is 1/2. Then we plug in our y and our x's, so y equals mx plus b. So 3 equals 1/2 of 4 plus b. So 3 equals, I'm warming up, y'all. Y'all get the bad handwriting when y'all come to this session. I should do some warm-ups in the morning, so it's not this bad. So then we get b equals 1. And so we can rewrite it as y equals 1/2 of x plus 1. Hopefully we got that. I'm going to erase this over here because it looks awful. But what we did is we just took our slope, we flipped it negative reciprocal, and went from there. So for parallel, we don't have to take negative reciprocal. We just take the slope as is. So we're just going to plug in 3 equals negative 2x plus b. I'm sorry, my throat is sounding not great. This shouldn't be x here, I'm sorry. 3 equals negative 2 times 4, because this is 4 is our x. And then so 3 equals -8. If you have any questions about this, feel free to go and start putting in the chat. Add 8 to both sides. And you get b equals 11. And so you write it as y equals -2x plus 11. Hopefully y'all got that. Hopefully that makes sense to you. If it doesn't, let me know. And yeah, we'll chill here for a second and then we will move on. Alright, cool. I guess we're good. So moving on. So what we're going to do now is we're going to try to work on finding the distance between 2 points, okay? And so if you think about our graphs, right? We have these graphs, and we're going to have a point like over here, and point down here, and we want to know the distance between these 2 points. If the points were on the same like y value or the same x value, we could do that easily because we just count, you know? This distance right here, you just count how far apart they are. For this distance over here, you just count how far apart they are because they're on the same x value, not the same y value. But when they're not, whenever we have a diagonal like this, we don't know the distance of this diagonal. This drawing's awful, but you'll see what I mean more on this next slide. And so we have to use special things to find that. And so what we're going to do is we're going to use the Pythagorean theorem, or we're going to use the distance formula. I don't think y'all know the distance formula, but we're going to go over it. Alright, Pythagorean theorem. Okay, so this problem here is we're trying to find the distance between these 2 points. Between, we'll call them A and B. Okay? Distance between A and B. My mouse is being weird. Sorry, let me fix it real quick. Alright, there we go. So, what we're going to do is instead of using anything fancy, we're going to go back to what we know. Okay? So we know if we draw a triangle coming down like this and coming over like this, okay, with the point being right here, this is a right angle. And we know when we have a right angle, we're like 1.5 slides in, so you can just hop on from here. You missed the warm-up, but it'll be alright. So we know when we have a right angle that we can do the Pythagorean theorem, okay? So if we call this side A and this side B and this side C, we can do A squared plus B squared equals C squared, right? We've done that before, okay? So now we just start plugging things in, all right? So this distance A is just 1, 2, 3, 4, 5. So we got 5 squared right here. This distance B is 1, 2, 3. 3 squared equals C squared. A squared plus B squared equals C squared. So we got 25 plus 3 squared is 9 equals C squared. 25 plus 9 is 34 equals C squared. So C equals radical 34. And that's it. Okay? So this C over here, this distance between these 2 points is radical 34. Radical 34 is a weird number. So we can plug that in our calculator. And it's about 5.8. So now we know that this distance here is about 5.8. And that's what we're looking for. That was our answer. And so nothing new here. It's just on a graph. The fact that it's on the graph is the new part. You have to be able to count. So I'm going to do number 11 with y'all again. And then y'all are going to try number 12 on your own. So number 11, we make our triangle. Oh, goodness. So we make our triangle, coming down like this and over like this, right angle. Alright, and so we want to find this C, and this is A and B. So we need to know these distances. So this distance, this left side, this side A, is 1, 2, 3, 4, 5, 6, 7. We got a squared plus b squared equals c squared. So a is 7, b is 1, 2, 3, 4, 5, 6, also 7. So 49 plus 49 equals c squared. Just Pythagorean theorem. Things we've done before, hopefully. Hopefully this all sounds familiar. Hopefully this is alright. 49 plus 49 is 98, I think. Equals c squared. So c equals, when you plug on your calculator, you get 7 radical 2, which is the same thing as 9.9, about. So C is 9.9. Alright, I'm going to give y'all a few minutes, let's say like a minute and a half, to try this one on the right on your own. And yeah. So try number 12 on your own, and then we will go over it, and then move on to the next part. So you got it. Try number 12. If you have a question about the past ones you did, throw them in chat. Hopefully we're starting to get where we get how this is working. Honestly, I haven't done it yet. Let me see. You're really close. See if you can find your mistake. It's not c equals 50. Alright, going over this. So I went ahead and drew my triangle. I went ahead and wrote my formula down. A squared plus b squared equals c squared. So here my a is 5. My b is also 5. So we're going to say 5 squared plus 5 squared equals c squared. And so 5 squared is 25 plus 25 equals c squared. So c squared equals 50. Then you have to square root both sides. So you get c equals 5 radical 2, which is about 7.07. So you forgot to square root both sides. You had c squared equals 50. Pause here for any potential questions, and then we're going to move on. Yeah, so you got all the way down to the last step. You just forgot the very last step. Alright, so hopefully we're good. I'll move on. If you have questions, I will absolutely come back to it. But yeah. Alright. So, our next thing that we're learning is the distance formula. Okay? And the distance formula, what you're doing is, it's basically the Pythagorean theorem written in a different way. But now we have a formula. So if you'd like to plug and chug, if you don't like have to figure out the Pythagorean theorem on your own, you can do it this way. Important things about the distance formula. Whichever is your second point, you have to make sure you use your second point on the y values as well. Okay? So it doesn't really matter which one we use, as long as we are consistent that the second point is the second point. If we put x2 here and y1 here, that's wrong. And then we lose. And then I'm sad. And then you're sad. That's no fun. So let's not do that. Other thing, make sure you put parentheses around your x2 minus x1 when you plug in your calculator and your y2 minus y1. And I would plug in x2 minus x1, plug that in, and plug the y2 minus y1. And then square them, then add them together, then square root. You can put them all in the calculator in one big giant step, but I find that more difficult. So, all we're going to do here is we're just going to write our formula out. Squared, that's an off parentheses, pretend it's perfect, because everything in life is always perfect, plus y2 minus y1 squared. If you ever run out of square root room, just make more. Alright, then we plug everything in. So I'm going to use this as my second point, and this is my first point. Okay, so my x2 is 6 minus negative 2, my negative 3. Sorry, x1 is negative 3. I nearly made a mistake. Squared. This is all going to be square rooted eventually. We do plus y2 is negative 2 minus y1 is 1 squared. Okay, and then we have square root of 6 minus negative 3 is the same as 6 plus 3, and so we're going to have 9 squared plus negative 2 minus 1 is the same thing as negative 3 squared. This is another thing you have to watch out for. This negative 3 squared, if you type it in your calculator as negative 3 squared, you're going to get negative 9. Okay, what you have to do is know that this negative make a positive, or you can plug in your calculator as parentheses negative 3 close parentheses squared, and that'll give you the correct answer of 9. Okay, so be really careful with this when you're plugging this negative 3 into your calculator. So we plug these in our calculator. 9 squared is 81 plus 3 squared is 9, still all square rooted. So then we have the square root of 90, and then the square root of 90 is, of course, 9.48. I did that with my calculator. 9.49. And then that's it. That's all this is. So you're just plugging in your calculator. If you think about this as the Pythagorean theorem, you can still plot negative 3, 1 and 6, 2. And then we'd have a giant triangle like this. And then what this is doing, just x2 minus x1, is just going to be this distance. Let me do that in another color. Oh goodness, I'm ruining everything. So the x2 minus x1 is just our a, and the y2 minus y1 is just our b. And so that's where this formula comes from. Alright, I'm going to do number 4, and then I'm going to let you all try one on the next page, and then we're going to be done. So stick with me, almost there. If you want to try this number 4 on your own and get a little bit ahead of me, that's great too, and then you can check yourself as you go. So formula is x2 minus x1 squared plus y2 minus y1 plug everything in. It's negative 4 minus a negative 1 all squared plus, be super careful with your parentheses, y'all. y2 is 1 minus y1 is -1. Then you just keep going down and simplifying. -4 minus -1. So -4 plus 1 is going to be 3. -3, sorry. Plus 1 minus -1. 1 plus 1 is just going to be 2. So -3 squared is 9. Plus 2 squared is 4. Square root it all, and you get square root of 13. And that's it. Feel free to ask some questions about this. I'm going to give you all a second to do that, and then we're going to go on to the next little part. If you wanted to sketch these and your own little graph and do the Pythagorean theorem, you can do that as well on most problems. There's going to be a few problems where I ask you to use one or the other, but that's just because that way I can make you try both. Alright, so I guess we're good. So try number 7 on your own, and then we'll go over it, and then we will pretty much be done. So yeah, try number 7, give you, let's say, 3 minutes on this, then we'll go over it in the final 2, and then we'll be done by 9:30. Feel free to ask some questions. I'm really just chilling, waiting for someone to need me. Alright, we'll go over this real quick. And yeah, so our formula is just x2 minus x1 all squared plus y2 minus y1 all squared, and square root of everything. So my x2 is 5, my x1 is 4, my y2 is -2, my y1 is 0, it's all square rooted. So 1 plus 1 squared, excuse me, plus -2 squared. And so 1 is 1, -2 squared is 4, let me get radical 5, and then radical 5, I used to know this off the top of my head, but I don't anymore, is 2.24. And yeah. Hopefully that makes sense. Hopefully you understand how to do that. It's just really just plugging and chugging. If you like the distance formula better, and you wanted to use the distance formula for like these graphing problems, you just got to find the points. So like this point up here is -5, 1. And this point over here is 0, -4. And then it's the exact same thing. If you like the Pythagorean theorem more, and you get points like this, you just got to graph the points real quick. So this one's -4, 3. So -4, 3. Ideally, this is a perfect graph, but it doesn't have to be. This one is 2, 2. And you just draw your triangle. And this is 1. This side's 1. This side is 1, 2, 3, 4, 5. Did I do something wrong? I did. Did I? Oh no, it's a new problem. I'm dumb. Sorry. 1, 2, 3, 4, 5. And then you can just do a squared plus b squared equals c squared to get radical 26. What do you mean post the pictures? While Emma's typing, I'm going to go and talk to y'all about the assignment that's due. It's due Tuesday night. Starting out, it's 12 problems. You can use the first few asks you to use Pythagorean theorem, the next few asks you to use distance formula, and then it's like your choice. And so, yeah, 12 problems. Just go in there, knock them out. Let me know what questions you have. Yeah. Oh, you mean like these? Like the slides, or like the answer key? Yeah, I can post the slides on. That'd be a good idea. Oh, another thing I forgot to say. Last thing I forgot to say before y'all leave. If you go to online and Google geometry formula sheet, Georgia, this link should pop up. It should say geometry formula sheet, Georgia Department of Education, Georgia DOE, I mean. Click that. This is the formula sheet that we would use on the milestone, and the distance formula is right here. So if you ever forget it, there's the distance formula. So yeah, I probably won't get to posting it until after the 10 o'clock session, but I can do that. And yeah, that's all I have time for y'all. Not all I have time. All I have for y'all. I have more time for y'all. If y'all have questions, you want to stop and hang around. If you want to start on the worksheet that's already posted on Google Classroom, I believe, and ask some questions about that. Yeah. I know some of y'all are tired. If y'all are done for the day, y'all can be done for the day, wake up and do this later. But it would probably be better if y'all can just knock this out real quick and not have to worry about it again. So completely up to y'all. And yeah, I'm going to stop talking, because otherwise I'll just talk forever. And despite how awesome I am, y'all don't want to hear that. Thank y'all for being awesome. See y'all on Wednesday. It's okay, Alan. You can just chill for 30 minutes and do the 10 a.m. session. You can watch the video, which I think is automatically uploaded, and start from the beginning. Yeah. So it's all good. We can just do the 10 a.m. Alan. Okay, cool. You saw that. Awesome. Yeah, I'm actually done already, Alan. It's only like a 30-minute lesson, and we're just chilling just in case someone has some questions about the worksheet. Alright, sounds like everyone's good. I'm going to go ahead and turn this off. Yeah, thank you all for coming. If you have some questions, just hop into the 10 a.m. or send me an email or get in touch with me somehow and we can get those answered. But, yeah, adios. See y'all Wednesday.